Let's start our tutorial with our summary like before. First point of today's tutorial, which is integration using substitutions. The main important point is when do you need to use this substitution. Some problems, if you make substitution in them, you will be able to solve them easily and you can evaluate the integral in an easy way. So when can I use the integration by substitution? When you have a complicated form or the angle of any trigonometric function or any compact form, then after making this substitution, the function can be easy for you and then you can evaluate this integral. First of all, the definite integration using a substitution, if u equals g of x is a differentiable function whose range is an interval I and f is continuous on I, then if you find that f of g and exists beside it multiplied by g dash of x, which is the derivative of what is inside the f. So after making the substitution that u equals g of x, so the integration will be integration of f of u multiplied by du. And the same case goes or applies for the definite integral. If you have limits here, just you will find the function at this point. So you will evaluate at x equal a u, which equal g of a, and at x equal b, you have to evaluate the second u, which is g of b. The second point is integration by parts. This technique is applied when you have a product of two functions with different types. So what are the kinds of these functions? The main rule or the basic rule here, basic rule will be if you have the integration of u multiplied by dv, this will be equals to u multiplied by v minus the integration of v du. But all in all, I will make you not memorize this formula, but in order to make a summary for this lesson, so the summary here, this integration or this technique of integration can be summarized to be one of the three groups. First of all, if you read this formula, you have u and dv, so you will use u and v. So the main idea here is u keep as it is and v, and you have dv, so you have to integrate the v. So the main idea to choose u and v, so dv must be chosen, which should be easy to be integrated. And then you will need to use du, and you only in the problem have u, so the selection of u must be to be a function easy to be differentiated. This is the main aim of this technique of solution. The main idea here is to select or to use the suitable select of u and dv. So as a summary, we have three groups of this problem: group number I, group number double I, group number triple I. First group, if you have a polynomial like x squared, x cubed, x plus 1, and so on, multiplied by exponential function or sine or cosine. Think with me which function of them to be used as u. For sure, you can make differentiation for both the polynomial and the exponential and sine and cosine. But the polynomial have a great property that the polynomial after differentiation it will be 0. So the derivative of x squared will be 2x, again will be 2, again will be 0. So the better selection for this problem to select your polynomial as u. And the second group is if you have a polynomial multiplied by the logarithmic function len or log and so on. Here the better selection for u, which will be the len. So I do not have, how can I integrate the len? But I can integrate the polynomial. So here we reverse the selection of our choice of u. The third group of this problem or this technique will be if you have an exponential function multiplied by sine and or cosine. In this group, it does not matter to select the exponential as u or sine or cosine, since both of them will not be vanished like the polynomial here in the first group. And now let's take some problems or examples in order to be able to solve all these problems. Let's start with problem number 1, which states evaluate each of the following integrals. You may need to make a substitution first before solving this integral. Let's start with problem number A, which states the integration of 1 over x ln x dx. Here, I can solve this problem using two different methods. First of all, if you divide both numerator and denominator by x, the integral will be in this form. So it will be integration of 1 over x over only ln x and then dx. And as you see, we have a function in the denominator and its derivative in the numerator. So this will be directly equal to ln of modulus what is in the denominator, which is also ln x. So it will be ln modulus x plus c, since this is an indefinite integral. And as I recall for you to revise with me the rule of integration, if you have the integral of something in the denominator and its derivative in the numerator dx, this will be directly equal ln of modulus what is inside the denominator plus c. This is the rule that is used in this problem. And if you need to solve this problem using the substitution, how can I use this, or how can I select the function to be used in the substitution? Here in this problem, you find that you have ln and 1 over x. And for sure you know that 1 over x is the derivative of ln x. So by making that let u equals ln x and then du equals 1 over x dx. In order to be able to check your substitution is correct or not, after finding the du, you have a function here, it should be written in the integral. يبقى يا جماعه باكد عليك تاني عشان تتاكد انت حلك صح ولا غلط، او السبستيوشن بتاعك دوت صح ولا غلط. لما تيجي تحسب الدي يو لازم تكون الفانكشن دي مالها جوه الانتجريشن بتاعك. طيب دلوقتي انا عايز اعمل ايه بقى؟ هريبليس. يعني ايه؟ So I equal integration of, in the denominator we have u, okay, and all of this which is 1 over x multiplied by dx, all of this called du. So I will write here 1 and here only du. So the integration of 1 over x or 1 over u du, which will be only ln of modulus u plus c. But here once again, do not forget to return back to your unknown at the beginning of the problem, which is x. So you have to return back to your unknown. So ln u, which is ln x plus c. Here, the main idea is that you can use substitution or not in order to be able to solve this problem. And let's take another one in order to be familiar with this kind of problems. Problem number B, which states the integration of from 3 to 4 root x squared multiplied by root x minus 3. So here, integration from 3 to 4 for x squared multiplied by root x minus 3 dx. Any one of you can solve this problem using any old rule from worksheet number 11. If you think about this problem, of course not. You cannot solve this problem using any old technique or any old method you know from worksheet number 11. So I have to go to directly for the substitution. But here, take care that this integral is a definite integral. So I have to change the variable and also change the limits of the integration. So in this problem, or in this case, we will make the following. So you have to make this substitution. For example, let x minus 3 equals t squared. Why I select t squared, not, for example, t, in order to cancel this square root. So in this case, in order to find the x, you have to differentiate both sides with respect to x and t. So here dx will be equals to 2t multiplied by dt. And now you have to find the new limits for the integral. So at x equals to 3, the t will be 0. And at x equals 4, t will be for sure 1, since it's a positive value. Now I have to write the new integral. So the integration will be, instead of 3, I have to write 0. Instead of 4, I have to write 1. The integration of root t squared and dx, which is 2t dt. And what about x squared? As you know, here you can find x in terms of 2. So x equals to t squared plus 3. So the x squared will be t squared plus 3 all squared. Now I have to simplify this expression, integration from 0 to 1, by expanding this expression. So the first term squared plus 2 times first times second, which will be 6t squared, plus the second term squared, which is 9, multiplied by root t squared, which is t, multiplied by 2t dt. And now I have to make a simplification for this problem. So the integration from 0 to 1 for 2t power 6 plus 12t power 4 plus 18t squared dt. And this is an easy integration. So the first term, which will be 2t power 7 over 7, I will add power 1 and divide it by the new power, plus 12t power 5 over the new power, which is 5, plus 18t cubed over the new power, which is 3, and you have to substitute from 0 to 1, and which will give you the answer of this problem, which is 304 over 35. And here in this case, you do not have to return back to your unknown, which is x. So this problem, it is a definite integral, so you make substitution and you change the limits, so you do not have to return back to your unknown, which is x, here like the example before. And now let's take or go to item number D, which is integration from -1 to -half of sine squared of 1 plus 1 over x squared dx. Here, this is a complicated expression or complicated problem of integration. So I have to make a substitution first. So what is the substitution here you have to do? You have to take all what is inside the trigonometric function in order to get an easy form or a compact form. So here you have first to let that u or t, for example, t equals to 1 plus 1 over x, and now you have to make the differentiation for both sides. So the derivative of t, which is dt, and the derivative of 1, which will be 0, plus the derivative of 1 over x, which will be 1 over x squared -1, multiplied by dx. So it will be equal -1 over x squared dx. And as a check for your solution, you have to check that this term is already exist in your problem here. So since this problem is a definite integral, you have to find a new limits like before. So at x equals to -1, t will be 1 plus 1 over -1, which will be 0 at the end. And then at x equals to -12, t will be, you have to substitute in this equation 1 plus 1 over -12, which will be 1 minus 2, which will be -1. So I have to write the new integral. So the integral now will be integration. You have to replace -1 with 0 and replace -12 with -1, and then it will be sine squared of t multiplied by the rest element, which will be dx over x squared, which is here exactly the same, but there is a negative sign missing, so I have to write this negative outside and then write dt. Now the question is, how can I solve sine squared t dt as an integral? You have to remember the identity that sine squared of t equals to half multiplied by 1 minus cosine double angle, which is cosine 2t. I have to use this form here in this problem. So the integral will be negative from 0 to -1 for half multiplied by 1 minus cosine 2t, which is an easy integration now. So the integral will be -half integration of 1, which will be t, minus integration of cosine, which is sine 2t, over the derivative of what is inside, which is 2, and substitute from 0 to -1. First of all, you have to substitute with ht by -1, and then replace ht by 0, and you will find the final answer to be approximately equal 0.2727, which is the final answer of this problem. And here once again I have to recall for you that you do not have to return back to return to your unknown, since this is a definite integral, so you do not need to evaluate or to make a return back to your unknown. And now it's time to go to problem number 2, which is evaluate each of the following integrals. I will start with item number F, which is integration of t e power 3t dt. Here in this problem, you have a product of two functions with different types, and here this problem can be categorized as group number I. So you have here t, which is a polynomial, multiplied by e power 3t, which is an exponential function. So I have to select that u as the polynomial. And here this is the rule, but I don't need you to memorize this rule. So how can I not memorize this rule? In order to not memorize this rule, work like me or do like me exactly. So here you will have u as t, and right here dv, which is all what is inside the integral, which is e power 3t dt. And now you have to differentiate this, which is du. So it will be 1 multiplied by dt, and the integration of dv, which is v, will be e power 3t over derivative of the power, which is 3. And now you have to make this scissor like me. You have to multiply this by this, minus integration of this by this. So it is uv minus integration v du, which is exactly what is written here in the form. So our integral will be I equals to t over 3 e power 3t minus the integration of e power 3t over 3 dt. And now we have an easy integration, so it will be t over 3 e power 3t minus e power 3t over 3 multiplied by 3, it will be 9 plus c. Especially this group can be solved in a way which we can call it the tabular form. Tabular form which will be only available or applied for group number 1. So in order to make a table like this, table here, and select one function to be differentiated and the another one to be integrated. So here you will choose for sure t to be differentiated. I have to differentiate t till reach 0. So the derivative of t which will be 1, the derivative of 1 which will be 0. And the other function which is e power 3t, I have to integrate this function till the same line. So it will be e power 3t over 3 and again e power 3t over 9. And now I have to make signs like this, multiply the first one here by a second with a positive sign, and second here with a third one which is a negative, will be with a negative sign. So directly our integral will be I equals to 2t e power 3t over 3 minus e power 3t over 9 plus c, which is exactly the same like before, but in a different and easy way. So you can use this tabular form in group number 1 only in order to make it easy for you. In order to make the idea clear for you, let's take another example, which is number G, which is integration of y multiplied by sine y dy. Here, this is also a group 1 problem, so I can apply the tabular form directly. So the tabular form, I have to select one to be differentiated and another one to be integrated, and for sure you have to select the polynomial here which is y to be u. So here y, derivative of y which will be 1, derivative of 1 which will be 0, and the other side we have sine y, the integration of sine y which will be cosine y, the integration of cosine y will be sine y, and I have to apply the sine rule, which is the first term positive and second term will be negative, and directly our integral will be I equals to y cosine y minus sine y, and do not forget the constant c, which is a constant of integration. Look, this is an easy way to evaluate this integration, and in order to make it clear for you, let's take another example which includes a higher power of the polynomial function. And now, what about number D, which is integration of x squared cosine mx? For sure, this problem is a type or group number I, since we have a polynomial here multiplied by trigonometric function which is cosine. So for sure I have to select this function to be u, or directly I can apply the tabular form. So the tabular form here, I have to select one to be differentiated and another one to be integrated here. So the function to be differentiated, which is x squared, derivative of x squared which will be 2x, derivative of 2x which will be 2, derivative of 2 which will be 0. And the other side, which will be cosine mx, I have to integrate this function till reach the same line of 0. So integration of cosine x will be sine mx over derivative of what is inside, which will be m. Once again, integration of sine x will be negative cosine mx over m multiplied by m, which will be m squared. Another one, which will be negative sine mx over m multiplied by m squared, which will be m cubed. And do not forget to apply the signs, which will be first term to be positive, second term to be negative, and third term will be positive. It is an alternating sign, positive, negative, and so on. So directly our integration will be I equals to x squared over m multiplied by sine mx, minus minus will be plus 2x over m squared cosine mx. It is minus, or sorry, it is plus, since we have this negative and also this negative, and now positive multiplied by negative, it will be negative, so it will be minus 2 over m cubed multiplied by sine mx. And do not forget to write for sure the constant of integration, which is c. And now let's go to number b, which is integration of theta sec squared theta d theta. As you know, integration of function of theta d theta is exactly the same like integration of function of x dx. X, theta, t, u, all of these are dummy variables. And now integration of theta sec squared theta, this is for sure a group 1 problem. Why? Since you can differentiate this function, so I have to use it as u, and you can integrate this function, so I have to select this as dv. So now here u, which will be theta, and dv, which will be sec squared theta d theta, and now the derivative of theta, which will be 1 d theta for sure, and integration of sec squared, which will be tan theta d theta. And now the ladder of our problem, which will be multiplication of this by this minus integration of this by this. So I will be equals to theta tan theta minus the integration of tan theta d theta. And now how can I solve this integration of tan theta? For sure, I know how can I solve this problem from worksheet number 11. So the integration of tan, what is the tan? Tan is sine theta over cosine theta d theta, and for sure here you have a fraction and you need to apply the logarithmic integration or the integration of the logarithmic function. So here in the denominator you have cosine x, and in the numerator you have sine x. And you know that the derivative of the cosine x, which is negative sine x, so you have to multiply by negative here and negative outside the integral in order to evaluate or in order to use the rule that theta tan theta plus integration, which would be ln of modulus what is inside the denominator plus c. And now let's go to solve number E, integration of x ln x dx. Here you have a polynomial multiplied by a logarithmic function. So this problem will be of type 2 or group number 2. So you have to select u as the logarithmic or the ln function. So now I have to make the format of my solution. So u equals to ln x and dv, which will be x multiplied by dx. So the derivative of ln x, which will be 1 over x dx, and now the integration of x, which will be x squared over 2, and now I have to make my ladder, which was multiplied of this by this minus the integration of multiplication of this by this. So I will be equals to x squared over 2 ln x minus the integration of 1 over x multiplied by x squared over 2 dx. And for sure you can make a simplification. You can cancel this power with this x, so the problem will be only x squared over 2 ln x minus the integration of x over 2 dx, which is an easy integral, so it will be finally x squared over 2 ln x minus integration of x, which will be x squared over 2 multiplied by 2, so 2 will be 4 plus constant of c. This problem, I hope it is clear for you. We use the second group, which is the first problem, to apply the second group of integration by parts. And now let's go to solve number A, integration of ln 2x plus 1. هنا بقى طبعا لو حد هيجي يبص على المسألة دي يقول لي ايه، هو هنا احنا عندنا لن بس ما عندناش polynomial function جنبها. ما انت ممكن تعتبر ان الفانكشن هنا البولينوميال اللي موجودة جنبك هي كام؟ هي 1. عادي جدا هشتغل عادي، هقول لك ان u equal كام؟ equal ln of 2x with dv equals to 1 dx. So the integration of ln, which will be 1 over 2x plus 1 multiplied derivative of what is inside ln, which is 2 dx, and now integration of 1, which will be x. And now by making our ladder, multiplying of this by this minus integration of this by this, so the integration I will be x ln 2x plus 1 minus integration of 2x over 2x plus 1. And now the question is, how can I solve this integration? First of all, you have 2x in the numerator and also 2x in the denominator. So you can use the rule that you can make plus 1 and minus 1. And for sure, this will not change the problem. And now you have to make splitting of the fraction. So you have to take this one over this one, and second one, which is this one over this one. So our integral will be x ln 2x plus 1 minus the integral of 2x plus 1 over 2x plus 1 minus 1 over 2x plus 1, all of this dx. Here I will make a recall for you what I did in this problem. If you have a plus b all over c, this can be split to be a over c plus b over c. And now for sure you can cancel out this 2x plus 1 and this 2x plus 1. So the integral will be x multiplied by ln 2x plus 1 minus integration of 1 minus 1 over 2x plus 1 dx. Now this is an easy integration. It will be x multiplied by ln of 2x plus 1 minus, open a bracket, integration of 1, which will be x. And this function for sure it will give you ln, but you need to have 2 in the numerator, so you have to divide by half ln of what is inside the denominator, which is 2x plus 1, and do not forget to write the value of c. And now let's go to number h, which is integration of e power 2 theta sine 3 theta. And if you look at our summary, this kind of integration, which can be categorized to be a group number 3, so it does not matter to select which one of them to be u. So I will use u as the exponential function. So u equals e power 2 theta. I can call this integration as I, and dv, which will be what is inside the integral, sine 3 theta d theta, and now du, which will be 2 e power 2 theta d theta, and v here it will be negative cosine 3 theta over 3, and our ladder here multiplies this by this minus the integration of this by this, and so I will be negative e power 2 theta over 3 multiplied by cosine 3 theta. This minus and this minus will be plus 2 over 3 multiplied the integration of e power 2 theta multiplied by cosine 3 theta d theta. And now here this integral also is a group number 3 integration. So I have to make integration by parts again. But here, since you start at the beginning by selecting the exponential to be u, you have to continue the problem using the same selection. Here, once again, I need to stress on this point. Here, you at the beginning of the problem select u as the exponential, so you have to continue till the end of the problem by using the same selection you choose at the first. So here I will make integration by parts again. So u equal e power 2 theta and dv equals to cosine 3 theta d theta du equals 2 e power 2 theta d theta, and v equals 2 sine 3 theta over 3, and I will make my ladder. So all of this will be used instead of this integration. So I have to write all what is I write at the beginning. So I equals to negative e power 2 theta over 3 cosine 3 theta plus 2 over 3, and I should open a bracket here, e power 2 theta over 3 sine 3 theta minus 2 over 3 integration of e power 2 theta multiplied by sine 3 theta, all of this d theta. And if you remember the problem at the beginning, we call it I is e power 2 theta sine 3 theta, and all of this integral, we can call it I again. So I equals to negative e power 2 theta over 3 cosine 3 theta plus, I will distribute 2 over 3, so it will be 2 over 9 e power 2 theta sine 3 theta minus 4 over 9 I. This is 4. I can erase this one. 4 over 9 I. And do not forget that your main target is to evaluate I. So I have to switch this term in the other side with different sign. So it will be I plus 4 over 9 I, which will be finally 13 over 9 I equals 2 negative e power 2 theta over 3 cosine 3 theta plus 2 over 9 e power 2 theta sine 3 theta. And in order to evaluate only I, you have to divide both sides by 13 over 9. So finally I equals to 9 over 13 multiplied by all the right hand side, which is negative e power 2 theta over 3 cosine 3 theta plus 2 over 9 e power 2 theta sine 3 theta, and do not forget to write the constant of integration. And this is a group 3 problem, and this kind of problem we can call it as twisted integral, since in the problem we got itself once again and we switch it to the other side in order to get the total value of the integration I. And now let's go to problem number 3, which is evaluate each of the following definite integral. The main difference between this problem and all previous problems, this is a definite integration, so you have to find a value at the end of this problem. Let's start by number A, integration from 0 to pi, t sine t dt. Here, once again, this is a group 1 problem, so I can directly apply the tabular form like before. So d by dt, and the integration of dt, here t and 1 and 0, and I have to integrate sine t, which will be negative cosine t, and the integration of cosine t, which will be negative sine t, and I will put my signs here positive and here negative with an alternating sign. So directly our integration will be negative t cosine t minus will be plus sine t, and here I do not write the constant of integration. I have to make substitution from pi to 0, so I will replace each t by pi, so it will be negative pi multiplied by cosine pi plus sine pi minus, by replacing ht by 0, it will be 0 plus sine 0. As you know, sine 0 equals 0 and sine pi equals to also 0 and cosine pi equals to negative 1. So the final answer will be only pi. So, as you know from worksheet number 11, the main difference between the definite and the indefinite integration gives you a function and the definite integral gives you a value. And now let's start problem B or item B in problem number 3, integration from 0 to 1 for x squared plus 1 multiplied by e power negative x. For sure, also this problem can be categorized to be group number 1, so I can directly apply the tabular form, which is an easy form for solving this kind of problem. So I have to select one to be differentiated and another one to be integrated. So for sure I will differentiate the polynomial function, which is x squared plus 1 multiplied by, or we will make differentiation for x squared, which will be 2x, and differentiation once again it will be 2, and differentiation once again it will be 0. And I have to integrate the other function, which is e power negative x. So the integration of e power negative x will be negative e power negative x. Once again it will be positive e power negative x. Once again it will be negative e power negative x. And denote sign beta, which will be positive, and then negative, and then positive. So the integral will be directly I equals to negative of x squared plus 1 multiplied by e power negative x. Negative positive will be negative 2x multiplied by e power negative x. Positive negative will be negative 2 e power negative x. And we have to substitute from 0 to 1 in order to get the final value, which will be approximately equal 0.792 by replacing first each x by 1 minus by replacing each x then by 0. And here, let's go to number C, integration from 1 to 2 for ln x over x squared dx. For sure, if you find ln, you have to use it directly as u. So if you take u as ln, so du will be 1 over x dx, and dv, the other term, which is 1 over x squared, so it will be x power negative 2, so the integration of this one will be negative x power negative 1. Now I will make my ladder to be this multiplied by this minus the integration of this multiplied by this. So you will find ln x multiplied by negative x power negative 1 like this, minus integration of 1 over x multiplied by negative x power negative 1 like this, and after simplification it will be x power negative 2. And but here, do not forget that the first part is finished, so you can substitute, and so I get its value. But the second part is still need to be integrated. So the integration of x power negative 1 will be x power negative 1 over negative 1, and I will make also here substitution. And final answer will be 0.1534, and this is the last problem of this worksheet.